So the next question, in a circular table cover of radius 32 cm, a design is formed leaving an equilateral triangle ABC. Find the area of the design. So this is the figure given. There is a circle, its radius is given as 32 cm, and there is a triangle on the middle, and in outer portion of the triangle is designed. Okay, and the question is to find the area of the design. So it is clear from the figure that to find the area of the design, what we need to do, we have to find the area of the circle. From the area of the circle, we have to subtract the area of the triangle. What is the characteristic of this triangle? It's an equilateral triangle. That means all sides are equal. Okay, so we will start. Area of the design is equal to, what all we have to do? We have to find area of the circle, which is pi r square, area of circle minus area of triangle. Okay, area of circle, it is pi r square. What about area of triangle? We have many formulas since it is given in the question that it is an equilateral triangle. The easiest formula is root 3a square by 4, where a is the side of the equilateral triangle. What's the value of pi? It is 22 by 7. What is r? R is 32 because radius is given as 32. So 32 into 32 minus root 3. What about A? A is the side of the equilateral triangle. Is there anything mentioned in the question about the side of the equilateral triangle? No. So we have to calculate it from the figure, isn't it? So what I am going to do is, I am joining OB. What is OB? O is the center, B is a point on the circle. So OB will be the radius, which is given as 32 cm. Again I am joining OC. What is OC? O is the center, C is a point on the circle. So OC is also radius, which is 32 cm. So to find BC, what I am going to do is, so what about the specialty of OBC? It's a triangle in which two sides are equal. That means it is an isosceles triangle. In an isosceles triangle, the median will be acting as a perpendicular bisector. That means altitude will be the same as the median. So if I am drawing a perpendicular bisector to BC from O, it will be 90 degree, and also D will be the midpoint of BC. Okay, it is a perpendicular bisector, and also that means it makes angle 90 degree, and also D will be the midpoint of BC. So instead of finding BC, it is enough to find a BD and multiply it with the 2, so that we will get the side of an equilateral triangle. So we are going with the finding the length of BD. So again, angle BDO is an it's a right triangle. Triangle BDO is a right triangle. So what about this angle? Can you identify that angle? That angle will be, can you identify angle O? Angle O will be 120. Why you know? There are three sides, AB, BC and this AC, isn't it? And if I join this, there are three equal angles, which all, one is angle BOC, second one is angle COA, and the third one is angle AOB. And all the three angles are equal. The total angle is 360, and so each angle will be 360 by 3, which gives you 120. Okay, and again, since I draw the perpendicular bisector OD, it will be acting as an angle bisector also. So what about this angle? That angle will be 60 degrees. Okay, so this angle is 60 degree, this is 90. Then what about this angle? This angle is 30 degree. Which angle? Angle OBD is 30 degree. So what we have to do? We have to find the value of BD. Either we can take 30 degree or we can take 60 degree. So we will go with 60 degree. What about sine 60? We have to, why we are taking sine 60? We have to find a BD, and we know the hypotenuse OB. So sine 60 equal to opposite side BD divided by hypotenuse OB. What is sine 60? Sine 60 is root 3 by 2 is equal to BD, we don't know, divided by OB is 32. 2 and 32 get cancelled, giving you 16. So we are getting BD as 16 root 3. Okay, we need the side of the equilateral triangle. Side of the equilateral triangle is BC. BC is equal to 2 times BD from the figure. BC is equal to 2 times BD, that is 2 into 16 root 3, which gives you 32 root 3. Therefore, side of the equilateral triangle is 32 root 3. So we are going to substitute the value. It is a square. We got the value of a as 32 root 3, and a square will be 32 root 3 into 32 root 3 divided by 4 is there. So this is equal to 22 by 7 into 32 into 32 minus root 3 and root 3 gives you the value 3. So 32 into 3 root 3. There is again a root 3 there by 4. 1 more 32 is there. 32 into 32 into root 3 gives you 3 root 3. So what is common here? 32 into 32 is common. So we can take it outside. The balance is 22 by 7 minus 3 root 3 divided by 4. So if I take the LCM, what I get? 32 into 32. 88 minus 7 into 3. 21 root 3 by 7 into 4. 4 and 32 get cancelled, giving you 8. So 32 into 8. 8 into 2, 16. 8 3 is 24 plus 1, 25. 256 by 7 into 88 minus 21 root 3 centimeter square. This will be the area of the designed portion. Okay, so here the formula is very easy to find the area of the design. Just we have to subtract area of the equilateral triangle from area of the circle. But the problem comes when to find the area of the side of equilateral, not area, side of the equilateral triangle. To find the side of the equilateral triangle, first of all, we must join two radii. Consider OBC as an isosceles triangle. Make the perpendicular bisector which acts as the median and also the angle bisector. This angle, which angle? This full angle BOC will be 120. Why? Because the 360 is divided into three equal portions. So this full angle is 120. As OD is the angle bisector, angle BOD will be 120 by 2, which gives you 60. Then we are going to apply the trigonometric formula. Sin 60 is opposite side by hypotenuse. By applying that, we are getting the side of an equilateral triangle as 32 root 3, and we will be substituting an area of circle minus area of triangle, and we are getting the value as 256 by 7 into 88 minus 21 root 3 centimeter square.